Welcome to the AWS Startup Day Security Crash Course. My name is Will St. Clair. I'm a solutions architect for AWS based out of our New York City office, working primarily with our education technology customers now. However, I do have experience working with a lot of other customers in our public sector verticals, higher education, healthcare, et cetera, all areas where security is a really high priority. And my background is as a software developer, Rails, Python, Java. In 2012, I was a software engineer on the Obama for America re-election campaign. Worked at a couple startups since then, and found myself at AWS just over 2.5 years ago. So what I want to talk about today is building your startup with keeping security always in mind. With security, you're always fighting inertia. You're always fighting the resistance, the ability to just do the default, the easiest thing, and that can be a little bit hazardous in this environment, particularly in a startup where you are used to making decisions in an incremental way, in a really as-needed solution. It can be really easy to put yourself into a lot of technical debt with regard to security, which can be really dangerous if you are working with sensitive data, personally identifiable data. This is stuff that could potentially risk the company once you start handling this data, and so it's important regardless of your industry. If you lose customers' trust because of a data breach, it will be hard to regain their trust early on. If you lose key customers because of a data breach, it will be hard to get those back. And if you get too far down the path, it'll be really hard to, when you do need to land that big deal with your customers, you do need to get, your audit, you need to have due diligence done. If you're too far behind, it will be very hard to catch up. And so it is important to, keep this in mind at all times and to not, diverge too much from security best practices as you're building and iterating really quickly. Enabling good choices from the beginning will lower the resistance in some cases. You won't be relying on maybe more basic strict measures if you have more advanced solutions available. And you really want to build that culture really early on. We can't cover everything in the hour, but I do want to cover the major interest areas and then do a little bit of Q&A afterwards. Visibility. So visibility is the foundation on which good security is built. Without it, you may not know you ever have a problem. You could be compromised, and and this does happen. Companies have data breaches that they realize, don't even realize until months and months in. And so visibility is the key thing you're trying to enable in your environment with security. And with it, you can be aware that the problem exists. You have the supporting data, you have the ability to assess the problem, and you have the opportunity to remediate the problem. Even if you have to rely on outside help for your security stuff, having this visibility is necessary just to get started with seeking that sort of outside advice. And the very first step to good visibility is log aggregation. I cannot emphasize this point enough. There are several key points in AWS where you'll need to set this up. Things like CloudTrail logging for your API calls. If you're using our CDN, access logs on your CDN, access logs on your load balancer, access logs for your databases and S3 buckets. All of these are things you need to make sure to turn on. But most importantly, you also need to aggregate them into a single place. You'll also need to set up logging for your application. Your application will be generating logs that you define. And you need to aggregate those into a single place and retain them as necessary for your security requirements. There are major benefits to doing this, but there's also some pitfalls I want to talk about and some things you might want to avoid. As your systems and applications grow, you do need to send these to a single place for processing. You really, really want to try for a single location. If you don't make this a priority early, what will happen is your operations teams and your developers will build ad hoc log aggregation systems to meet operational requirements as needed. And it will be fine because they'll be able to troubleshoot and get the information they need from logs, but that's not adequate for security. It's not adequate for anyone coming in trying to do analysis on the system to detect or remediate an incident. It is not adequate for your own purposes. You really, really, really should try to aggregate your logs into a single system very early on. If you are not able to do that, it's something your security consultants will gladly do for you after you have declared an incident and are looking down the road of a data breach. But let me talk about some of the technical considerations for handling your application logs. looking at the very beginning, if you are looking at the framework you're using, you can first start filtering on the host. Depending on the amount of, the type of logs and the amount of logs you'll need to send. This includes obviously the output of your application. Your application needs to be logging the very, at a very minimum, the source IP addresses, the users, any authentication information, any sort of activity a user is performing. You don't want to leave that data behind because you need to be able to trace the steps of a user through the application. However, that does not also mean that you're leaving debug on. Those sort of situations can lead to can create a problem where you are filtering on maybe all the stuff on the host, which is burning up CPU on your hosts. And then when you actually do need to push debug out, you can create a production incident because this is not something you tested and the log volume is very high. So filtering at the host, be careful, log exactly what you need and only what you need, and try not to do too much more because it can cause issues. Another approach is to just log everything always and send it to the log tool to filter out. This is a common approach if you know what you're sending. Depending on what you're logging from the system, this may or may not be sufficient. If you're grabbing a lot of stuff from the system that you don't necessarily control, maybe things like audit D-logs, you can overwhelm the log tool. And if you're using a third-party log tool, cost is always a concern. The corollary to making sure that your logs are always aggregated to a single place tends to be that if you do choose a commercial tool, if you do charge something that's going to be licensed, they're typically licensed by the amount of logs you're ingesting. And I've seen cases where customers were like, well, yes, we have this to aggregate our logs, but we can't afford to send any more data to it. That's not a situation you want to be in. If cost is an issue for a commercial tool, my recommendation is to try to find another tool that's free. Manage it yourself using an ELK, Elasticsearch, Logstash, Kibana stack. Manage it yourself using Graylog. Don't try to use a commercial tool for some things and a free tool for other things. It's really important to get it all in one place. If you can't afford the commercial tool, you can't afford it. Don't let that be a blocker for you. The other thing too is that if you're pushing out a lot of this data to the aggregation point, you need to make sure that you're actually using it. Is this stuff that when I'm pawing through it, when I'm trying to figure out how to detect anomalies, that's actually useful. If I have logs and logs and logs full of hundreds of hosts that are open to the internet, getting thousands of SSH failed retries, that's just one example of log data that may not be actually very useful. Or maybe you may have even lower level system stuff that's filling up your logs. So do be judicious. You're looking at a logging for a security purpose rather than an operational purpose. If you have higher volume operational logs, you can consider sending those to maybe a separate system that doesn't retain them for as long. As you grow your footprint, what you'll typically see is some sort of logging aggregation layer. This log tool is primarily used for analysis and exploration. You may get to the point where a single syslog machine or a single machine running that tool is not adequate, and you want to look at something to aggregate it. This is where your stream processing tools come in, your Kinesis, your Kafka, potentially any third-party tools. This can help handle queuing. If that log tool at the very top is something like Elasticsearch, you can very easily get into a situation in which you have more log volume than your Elasticsearch cluster can index new documents, which can be a problem. So you want to make sure that your log aggregation layer allows you to, maybe pause a little bit. You can scale up your Elasticsearch cluster, then pick up the stream where you left off to send the rest of that data into the logs. So again, this is going to be a cost-benefit operations trade-off. It's more to manage. It's not necessarily needed in smaller environments. And you are talking about potentially about a lot of network traffic. Again, this is what this architecture would look like. And as you start using this log data, having that aggregation layer opens up a few other applications for you. At the very beginning, you're going to want just basic log searching. But going forward, you're probably going to want things like real-time analysis, things like Kinesis streams allow you to query the stream using SQL in real time. You can create derived metrics from that using CloudWatch logs and CloudWatch alarms. And potentially you may have other consumers. Maybe it's going into an Elasticsearch cluster on one end, but maybe you have another system that's pushing it into Redshift for a different type of analysis. Or maybe you have another system that's pushing it to S3 for long-term storage. And so as you start needing to retain these logs, particularly if you need to retain these logs for compliance purposes, multiple consumers of the stream are going to be pretty common. Moving on to the sort of next most important topic here is making sure that you're setting up your environment with least permissions. I know I'm as guilty of this as many of you are. When you start working in a new environment, particularly one you're unfamiliar with, it can be very frustrating to be running into access control errors all the time. So you just blow everything open to administrator, and you're like, I'll sort it out later. It is very important that you do sort it out later. As you're building your system, you need to consider that you're operating with least permissions on the individual host level. Think about your individual Unix users. You need to make sure you're operating with least permissions at the network level. Are hosts talking to only the correct hosts? Do I have monitoring and logging to make sure I'm aware if a host is talking to a host it should not be? As well as the what I like to call the platform layer, or the AWS layer. You're logging in. Are you logging in with root? Are you logging in with super user? What permissions are people using? And how can I not necessarily lock them down, but maybe force a two-tiered access strategy where if someone needs to log in to AWS to do something administrative, rather than trying to write a complex IAM policy that covers all of the use cases, maybe I can say, okay, you have a read-only policy and a read-write policy, and whenever you assume the role to get to the read-write policy, it pops a note in Slack or sends an email to the team. Same as if you were sudoing or something on an individual machine. Processes and files, really basic, just Unix hygiene. Run each process as its own user. Don't operate as root. Use file system permissions to restrict or allow access to data. You don't want, particularly multiple processes running on the same machine. You don't want them to be able to, walk on each other's resources. Services like Security Enhanced Linux, if you are familiar with it, can help. Maybe a little bit deeper there. And the key part is limiting network access with security groups. If you have experience sort of designing a network or multiple network zones on an on-premises network, you may be tempted at first in AWS to create a really nice, what I like to call ravioli-type architecture of lots of different subnets, and certain subnets can talk to others, but there's no real patrolling of traffic between zones, or there's really no patrolling of traffic zone A to zone B, but if app 1 is talking to database 2, that's a problem. In AWS, it lends itself more to an architecture where you can have a much flatter network, fewer subnets. You're not relying on the subnets themselves, but then security groups allow you to symbolically control, app servers A should only be talking to database A, and app server A should only be talking to load balancer A. Whereas, in a zoned architecture, all the load balancers can see all the app servers. And just simple stuff like that, one, it makes developing your network and deploying your rules much easier, but it also allows you to take advantage of things like VPC flow logs and get alerts when traffic that should not be crossing boundaries is attempted. So if you, for example, have a machine that gets compromised, you can say, hey, that app server A shouldn't be talking to database B, and app server A definitely shouldn't be scanning the subnet for ports, so open ports. So you want to make sure that you're taking advantage of security groups, and it works nicely because it's less work to do it symbolically than it is to do it just based on IP blocks. Locking down SSH. First thing I would do, I'll talk a little bit about your network design in a second, but just make sure SSH is not open to the world. Easiest way to do this is to make think about your AWS network as your production network. Create a single bastion host that you need to SSH through to get to any of the hosts on your network, and then lock down who can get onto that bastion host. Typically you're going to create a security group with say if you have a half dozen engineers, their home IPs, maybe their the office address. Just that basic step. With a small number of engineers, it is manageable to just whitelist that. Can be a huge help in cutting down on log noise. You know that a failed authentication of SSH is meaningful if you're locking it down to a smaller number of IP addresses. And just to, as a best practice, you don't want your SSH tunnel for your Bastion or SSH for your Bastion host to be open to the world if you can at all avoid it. Don't use passwords, use key-based logins. And in addition to that, visibility is the name of the game. Turn on email notifications with PAM. Have it push into Slack, do something just so that you know when people are logging into Bastion hosts. Maybe if you log into Bastion hosts, it cuts a ticket, and then they have to log what they did while they were into the Bastion host. Other things, Duo Push has a PAM module, I believe, that allows you to do MFA for SSH. There are a few companies that have published open source tools for doing two-factor with YubiKeys, which is pretty clever. Key thing is you just want to make sure that you are not using passwords, not open to the internet. The more aggressive strategy you can do is restrict SSH access entirely. If you've taken a more immutable approach to your infrastructure, let's say that you're building Docker containers, you're pushing them out into production, or you're building Amazon machine images and you're pushing those out immutably, sort of Netflix style. Maybe you don't have a routine need for SSH access into your hosts, and that's a good thing. So one thing you can do is take advantage of a service, what we call EC2 Systems Manager, as a feature called Run Command. What Systems Manager does is it provides an agent that runs on the individual instances. You just set that up in your init script, and registers with AWS. Uses the keys that you've set up in the same instance role, and then you can from AWS send commands to that host to be executed. So that could be you directly just sitting in the console, or it could be something like a script where it's like if I need access to this host to do a one-time debug, I run this Lambda function that adds my user account to this host, and then after 12 hours or whenever my access is expired, pulls it off. And so using run command, you can just have no SSH, built-in SSH by default. There's actually a really interesting talk I presented with FINRA, which is the Financial Industry Regulatory Authority, at the one of the summits this summer, I can't remember which one, on the system that they built to do this. Their reasoning was that they had because of their compliance environment, regulatory environment, had a fairly lengthy process to approve individual user access to machines, right? The rules were written in the days of mainframes and big racks of servers. If someone needs a login on a machine, you have to fill out paperwork. And so what they did was, look, let's just get rid of all of this. And if someone needs access to a machine, they go into this application. We set it up for them for X hours, and it creates this audit log right there. And if no one needs to log into a machine, there are no user accounts on this machine. And so that's something that you can do with Systems Manager. Again, this is more of an advanced technique, but it does give you an idea of how can I reduce my exposure, how can I limit the access that users have to individual hosts without necessarily impeding their work. If I can go in and create an audit log, and create a user account right then, I don't have to figure out how to manage and deploy SSH or user logins across a bunch of different machines. I don't have to set up an LDAP server. I don't have to write a Puppet script to distribute Etsy password everywhere, et cetera. Let me talk a little bit about encryption. Encryption is primarily going to be broken down into encryption in transit. How do I ensure that data is secure between two endpoints that might be traveling over an untrusted network? And encryption at rest. How do I make sure that if someone grabs a hard drive and inspects that there's nothing but encrypted data? But encryption at rest is often more of an issue with compliance. Customers will come to you with RFPs, and there aren't many anymore who will not ask you if data is encrypted at rest. So let me talk a little bit about both requirements. Something that a lot of customers do when they first get started is they try to take the approach of, I'm going to encrypt everything, and they look up how to do it in Linux. They're like, oh, I just have a transparent IPsec tunnel across all of my hosts in my microservices environment. A lot of times there are overlay networks, particularly if you're using container orchestration tools that will do some of this for you. But it's not an approach I love. It can be a little bit fraught for key management reasons. How are you authenticating that the endpoint that you're connecting to is actually 10.x.y.z, you need to bootstrap that on every single host. And it's also very hard to troubleshoot and debug. IPsec is operating at the kernel layer. The user space tools to do key negotiation, everything are not user-friendly. And it can be a little bit hard to troubleshoot. So typically when we do talk about encryption in transit, you're going to want to focus on TLS, particularly if this is a new application. Most architectures you're going to see these days are API-based, based on HTTP or something similar. And TLS is the way to manage that encryption in transit. Even with your database connections, TLS is the way to connect to your database with encryption. I wouldn't try to get too clever here. It abstracts away from your OS level configuration. It's usually configured in the host. If you're using our managed tools like Elastic Load Balancer will terminate TLS for you at the edge, but it'll also allow you to do TLS connections to your backend servers, so that your data is encrypted even as it passes from the load balancer to your instances in AWS. Again, you might still need IPsec for legacy applications, particularly if you are doing VPN type stuff between you and an existing customer. But otherwise, I would really try to focus on operating in TLS in your environment. Encryption at rest. It says here many customers. I would say most customers are going to require encryption at rest for any sort of data that's sensitive at all. It's for compliance reasons or because their downstream customers require it. They're getting an RFP from a K-12 school district, and so they're sending you an RFP that that says we need encryption in transit or encryption at rest. And importantly, if you're doing anything healthcare related, if you're handling personal health information, this could even be things like research, working with universities, medical students, et cetera. Our BAA, our business associate agreement under HIPAA, requires you to encrypt all data at rest and in transit at all times. Luckily, the best way to meet this requirement in AWS is to use EBS volume encryption. The AWS Key Management Service secures the master key material itself. These are hardware security appliances that we manage ourselves. Master key material never leaves our appliances, and then it then creates child keys encrypted with that master key and manages the permissions to the authorized principal. In this case, a given EC2 instance is the authorized principal. It's identified with its IAM credentials, and it goes to KMS, gets the encrypted key for the EBS volume, uses its own credentials to decrypt it, and then fully manages the encryption on the underlying EBS host. And all you have to do is check the box. The other really nice thing about using KMS encryption, which is both available to you as an application developer and built into the platform, is that it allows you to get really detailed audit logs of who used what key and for what reason. So if you're looking at your CloudTrail logs, you get the standard API call and audit logs that you'd expect. Things like so-and-so logged in, so-and-so created an EC2 instance, so-and-so terminated an EC2 instance. But it also says so-and-so created an EC2 instance, and then such and which EC2 instance got the EBS volume key. And then so you can really look at the logs and trace who used this key and for what. Similarly, you should be encrypting data that's going into object stores like Amazon S3. Similar to EBS, this is transparent. It's not something you have to worry about on your application layer. But it is something you do need to configure in order to enforce it. The way that you manage this in S3 is by creating an S3 bucket policy that says that I can only write to this bucket if I've set the header that requires encryption. So what happens then is that I write an object to S3. If I do not specify an encryption algorithm, the bucket will reject the write. If I have, then S3 will encrypt the object at rest using the keys that it's managing itself. Again, this would be a requirement. It's a best practice, but it's also a requirement. It would be a requirement if you're operating with personal health information. Similarly, outside of AWS, you're going to need to enable and enforce full disk encryption on your user endpoints. That is the individual desktops and laptops that you're issuing to your engineers and other employees. This is, I would recommend taking as a fairly early step. You don't want unmanaged devices or devices that are not company-owned, accessing company resources, particularly if those individuals have access to production, because you need to be able to account for which computers have given customer data on them. If you're doing a pilot project for such and which company, and they give you a bunch of data, and then one of your engineers is using his personal laptop to debug production, and then that engineer leaves his laptop in a cab, can't remember if it's encrypted or not, you have a data breach, and you are short one customer. So I would highly recommend, as soon as you start dealing with real data, locking down getting your user endpoint story straight. You should be on company-owned hardware, at the very least company-managed hardware. Meaning that you're imaging it yourself, you're managing the settings on it, you're limiting who has access to local administrator. And to do this, you should be using the native solution that your platform provides. On Mac, it's called File Vault. On Windows, it's called BitLocker. Chromebook, it doesn't have a cute name, it's just built in. And you also need to enforce it somehow. This could be just by provisioning laptops yourself before issuing them to users, and then making sure they don't have the permission to turn it off. Or it could be with a more complex endpoint management solution. That's probably a ways down the road for a lot of startups, but you do need to have some sort of records and have some sort of procedure so that laptops with company data are encrypted, period. Whether or not you need to invest in automating endpoint management, because it can be time-consuming and painful, depends on your customer's security requirements. As you sort of get down the road with real data, you are going to be asked to fill out security questionnaires, potentially going to be asked to seek third-party audits. That's the situation in which you really might need to start investing in endpoint management and security to meet those requirements. I've seen that happen with a lot of customers, particularly startups, they get down the road, they maybe even get to the point where they have dozens of employees, then all of a sudden they want a big juicy contract from a big company, they want to do a proof of concept, and all of a sudden they get the security questionnaire and they don't have a directory server set up, they don't really have a good checklist of procedures. So far the data has not really been an issue, and they have to invest a substantial amount of time and effort into a project to get their endpoint management cleaned up before they can even move forward with this customer. Keeping systems updated. So in the old days, you bragged about how old your servers are, how much uptime your server had. However, having those sort of long-lived instances, and I've certainly have customers in AWS who have instances that are 3, 4, 5 years old, increases your risk of configuration drift. It's not that there's anything intrinsically wrong. You could be updating the software every week, but it's very easy to lose track of how that server was configured. If I were to lose that server tomorrow, could I build a new one? Very easy to say if that server's only been around a week or two and you haven't logged in and messed with stuff. After that server's been online for 3 or 4 years, much harder to say, yes, our Puppet scripts still work on this server. I've worked with customers who have, even if some of their environment is under configuration management, they have, maybe 1 or 2 sort of pet servers. Oh, this runs all the cron jobs, or this runs all the scripts. It can be very difficult to secure an environment like that because you don't have the ability to create a clean environment. Worse, it increases your exposure and risk of security vulnerabilities. You need to make sure that your servers are always up to date. AWS publishes an RSS feed, for example, of critical vulnerabilities and updates to the Amazon Linux AMI. The other Linux distributions do so as well. And one thing you should be doing is watching that so okay, do I need to rebuild my environment, or run apt update on my environment, right now, or can I do it at the end of the month? Following those update streams is really critical. Instead, it's fairly important to start relying on automation early. Containerized architectures make this easier, but I would also add to that you do need to build in updating the software into your container pipeline. You don't want a situation in which people are building containers on their individual developer desktops and they're shipping those straight to production. They call that sort of the mystery meat of containers. and it can be a very hazardous situation for security, because then when an OpenSSL vulnerability drops, or a big Linux kernel vulnerability drops, question is, I guess the Linux kernel wouldn't be the thing, but particularly in the application software, how do I go through my environment and make sure this is remediated? If your environment consists of 30 different microservices with Docker containers built running different Linux distributions and different application stacks, there's no cheap way to say, okay, we've remediated this old version of OpenSSL and all of them. So particularly if you are in containers, you need to standardize the building of that process, and you need to make sure that you're not sending developer-built containers into prod. One caveat here, particularly around immutable infrastructure, is I've heard customers tell me, oh, our environment is safe against attackers. They can't be persistent because we rebuild all our servers, maximum every 7 days. So most anyone can be in there is 7 days. That is not necessarily the case. I've heard of and talked to customers who have seen much more advanced persistence techniques than that, and it can also deprive your ability to do forensics and analysis on the environment. So rebuilding your host frequently is not a cure for the risk of compromise. If you're deploying vulnerable hosts into production, then those hosts can be immediately recompromised. You can still have a persistence problem. And so one thing I would add to that is making sure that the hosts that you are deploying into production are up to date and patched. But then you're also potentially holding on to images of hosts, particularly critical hosts, for a set period of time for forensics reasons. If you are churning and burning all these hosts, and then for some reason you need to have someone come in and do a security investigation, you're not going to be able to do it if you don't have any images of hosts that you've killed. So just an FYI, it's not a cure-all to constantly rebuild your environment in an immutable way. Application security. So up to this point, we've just talked primarily about your platform, your AWS, your network, your users, your endpoints. But you also need to think about how you're handling security in your application. This will be fairly framework and language dependent. So I would definitely, if you have not, take the time and research, take the time to research it. Take a look at the kind of vulnerabilities that are common for applications built in your framework or language. Every single one has its own quirks. If they're big open source projects, you can usually see the list of disclosed vulnerabilities that they've found. You want to get a feel for the kinds of things that your application could potentially be vulnerable to. Security used to not even be part of the development process. As companies began adding it, the skills were somewhat specialized, and that they're often sort of tacked on to the end of the pipeline. You deploy everything, and then the security folks come in and run the vulnerability scanner. It's often too late. Positioned at the end of the pipeline, it really pits being secure against being fast to market, and you really don't want your security teams to be the final blocker to production, because it's not going to end well for security. Now application security is something that's a little more generalized and ubiquitous. And it's something you should consider moving up further into the pipeline, particularly as you're moving to containers. If your container if your deployment artifact is actually regardless of whether or not your container artifact is a jar file, a zip file, or a Docker container, you want to make sure that you're performing some sort of security checks further upstream than that. Am I running the latest versions of things? Am I running, depending on libraries, particularly if I'm using things that might have embedded versions of libraries I can't control. Tools like AWS Inspector can help with this. There's also additional third-party tools that you can buy. Simple rules, just really basic. Make sure you're always code reviewing your application and infrastructure changes. Particularly if you're building a new environment, there's no excuse not to be treating your infrastructure code as application code that's checked into your Git repositories. If you have AWS resources, that should be managed as CloudFormation templates or Terraform templates. If you have users and groups, that should be managed in a configuration file somewhere. That shouldn't be something that you're just point and clicking to manage. You already have a review process for code with pull requests in your source code management tool of choice, and so you should leverage it to the hilt. You really want to make sure that you have eyes, at least 2 eyes on everything before it moves out. Even if you're a small team, it will save you operationally, and it will also help you from a security perspective. Don't store credentials in your application. The solution that I like is called EC2 parameter store. There's also some third-party solutions that do something similar, leveraging DynamoDB and key management service. But what parameter store basically allows you to do is, I have an EC2 instance that has an instance role. I'm reading to a particular parameter. That's encrypted under the hood, and AWS is authorizing that request for me. And so you can just inline it in shell scripts as your configuration files, because you don't want these in your Git repository. I know some people mitigate this. I'll have encrypted secrets in my Git repository, and you have a chicken and egg problem of how you're deploying the encryption key onto those hosts in the first place. I would stick to the most managed solution you can find. There are a lot of them, particularly now with some of the later tools, but I like parameter store. Avoid added unnecessary dependencies to your code base. This is what I mentioned before. Make sure you know what you're pulling in. If you're pulling in something that has its own copy of OpenSSL, it's fairly common. Make sure that you're aware of that so that you don't find that you're running a vulnerable version of OpenSSL for 6 months. And always build for reliability and performance. You want to make sure part of having a CI/CD pipeline is to increase the reliability of your deployments. And the other thing about it is to make sure that you're performing the same tests and checks and everything. And so that extends not just from security, but to operations. Let me talk a little bit about database and analytics. Just real quick here, same sort of procedures for databases and analytics. Sometimes the database guys can get a pass. They're sitting there in front of their SQL console all day and manually managing the database. You really don't want to do that. That should be pushed through the same code review process that you're handling your security changes and your code changes through. A lot of frameworks, I would say probably most frameworks, hopefully, that you'd be using nowadays have built-in solutions for this. Think about Rails migrations, et cetera, equivalents and for other ORMs. Make sure that your same sign-off procedures apply. This could be pull requests. This could be Slack bots, et cetera. For analytics or end users of your databases, a lot of times you will have users who are working in maybe a data science role or a business intelligence role. You can often start out doing this by creating users and groups in the database. This is an all-right solution. It does mean that you need to manage the users and groups in the database. You need to figure out how that integrates into your onboarding and offboarding. You need to figure out how you are monitoring that. If someone is connecting to the database directly, you want to make sure that that's popping up in your logs somewhere. But it may be easier to manage that access through some sort of application layer or a BI tool. Tools like Looker, Metabase, QuickSight. This is a little bit cleaner than managing users in those databases and can also provide a richer interface. Audit all activity. You want to limit the number of users with direct access to the database. You probably also want to do this for operational reasons. You don't want to take down the production database because you're running an ad hoc query. But you also need to be able to answer who logged into the database when. Real simple. Query logging can be a little heavy, I understand, but you do need access logs. Office IT, really quickly, you have, as you start to grow your network, you have your AWS network, sitting in your VPC. You also have, however you're getting to the internet, your Office network. Your Office network, most smaller companies I've seen start out, they usually have a couple wireless networks, maybe one for guest and one for the corporate network. I would recommend 3. one for guest, one for the corporate network or the actual secure network, and then another one for your in-office IoT and embedded devices. You really want to limit the exposure of your corporate resources to endpoints that are sketchy and untrusted. If you buy something off the shelf at like Southern California Fries, and it gets access to the internet, you want to make sure that it can't also scan your corporate network because you're not managing the firmware in that device. If you have an office network, it can be really tempting to just blow open the whole network to your production network. I would recommend not doing that. It might make sense to create an office-wide corporate network if you have a lot of physical workstations at first, and that maybe they're accessing internal web applications. I would do note that that's not sufficient for authentication, though. You still want some sort of single sign-on layer, whether that's old school, Active Directory, Kerberos, or whether that's something newer, based on SAML, Okta, using Google Apps as an identity provider, et cetera. Just because someone is on the corporate network does not mean that they're authorized to access an application, period. I would take a hard line on that early. It's so easy to set up authentication with the tools that are available out there these days. Almost everyone is using some sort of identity provider that supports SAML. But before you get to that point, it's very common to set up individual VPNs. My preference is to still limit access to your production network through a Bastion host. Just because you're connected to the VPN doesn't mean that you should be able to log into all 20 hosts in your production network, all the databases. You may want to mediate that access somehow. But again, it's fairly common to set up OpenVPN or another tool to provide that access both for users in your office and for road warriors, so to speak. MFA. It's 2017. There's no excuse not to MFA as much as you can, which should be everything that is web-based, at the very least, potentially also SSH. All of the, all or most of the SaaS providers and things you should be using should support MFA. If not, you should give them a hard time. And then any single sign-on providers that you're integrating with should also support the ability to have MFA, then get into the extra other applications via SAML or OpenID Connect or OAuth. Again, people are fairly familiar with what MFA tools look like. YubiKeys are nice because it actually performs mutual authentication with a number-based token, or a particularly the ones that you have on your phone. It's very easy for a phisher to provide front that and then just capture your token in the middle. YubiKey is actually authenticating that you are looking at the website you originally looked at. So if I try to log into some application, I set up with my YubiKey token on, and some phisher has set up a fake website, my YubiKey will not recognize that as the same site that enrolled it. So if you can prefer more sophisticated solutions, although in a lot of cases you will be just using the standard TOTP-based or the Duo push. Logon notifications. This is just, I mentioned this before, another touch on visibility. This is something I like a lot because it's low effort and it's really useful. People log into things, drop a note in email, drop a note in Slack. Again, I already talked about Office IT a little bit. As you grow, you probably will start looking at the more advanced modes of operating a network using 802.1x and more advanced endpoint management. This is probably down the road of more advanced endpoint management, so I'm not going to talk a whole lot about it. But do note that you should not, if you're using WPA2, you should not be relying on the encryption on the connection to prevent eavesdropping. If someone has the pre-shared key to a WPA2 network, if they can sniff the handshake, they can decrypt the traffic. So even on your internal network, you need to be using TLS for TLS or SSH for all your hosts. No clear text traffic anywhere. Office IT again. I don't have to sell this audience on the benefits of SaaS, but when you can, web-based interfaces make it much easier to control access, limit the amount of data that people tend to have on their end user machines, and no need to update and manage updates on the endpoints themselves. Anyone I'm sure who's worked in a corporate environment is familiar with update nags, and so the minimal amount of those you can get away with is important. Phishing. This is one of the easiest and most common ways that an environment is compromised, particularly if you look at your access into SaaS tools. You should train your employees to be aware of phishing, but be aware that research shows this is not sufficient. Even sophisticated users can and will fall for phishing attacks. So train your users, let them be aware, let them know, but you should also know in the back of your head that you could still get phished. So you need to implement other measures to mitigate that. And typically the way you do that is multi-factor auth, login notifications, and visibility, visibility, visibility. You want to know who is doing what at all times. Social engineering. This is really important. As you start working on customer service, if you have customers, you want to make sure that you have very clear procedures on the authentication level for say a user calling in with a support issue. You don't want to be really easily engineered into giving out or resetting a user's password or changing the ownership of a user's account, particularly if you're working on an app that could be handling sensitive data. And so it's very important that you sort of set those standards and procedures early on. And your employees just should generally have standard operating procedures for working with outside people. You want to make sure that users are, other people are authenticated before you, start doing things for them in your environment. Security training. Always make this part of onboarding. Topics cover how to request access to systems, how to report phishing attempts, data classification. One way, data classification as you start to handle more complex data or sensitive data is important because it gives you a guide on, if I'm an app developer, how much do I need to worry about a given piece of data? Is this a piece of green data? Is it public data? Is it a piece of yellow data, maybe something that's confidential but not world-ending? Or is it red data? Is it customer data? That's going to inform decisions like what encryption systems do I need to use? What sort of network precautions do I take? How much logging do I need to have around access to this data? You don't want to fill up your log servers logging everything, but you do want to maybe have more granular logs for actions that are affecting more highly classified data. Identifying false browser messages and warnings. Who and how to contact someone in the event of an emergency. You may be, before you have full-time security, you may need to designate someone to be that security point of contact. And most importantly, knowing it's okay to ask others if something seems off or wrong. You don't want to encourage people to cut corners on security. Always better to ask. Ticketing systems and access requests. You should establish a single ticketing system for security and operational purposes early that the entire company uses. Email and Slack are not good substitutes for this. This should also be integrated with your paging and notification system, whichever one you use, because you'll also want this to be your source of truth for how events were handled and notified. This is your system of record. You'll probably will end up with other systems for project management. Those tend to have a different feel to them than like an operational security ticketing system would. Customer service will probably be a separate system. But you really, really want to try to use a single system for security and operations. This is similar to the issue with logging systems, where if you do not make a choice and enforce it early on, you will, I guarantee it, end up with 6 different ticketing systems that 6 people prefer separate ones. So this is your system of record. This is where requests for access need to go in. This is where alarms need to go so that you have a log of who handled it and when. I really, really, really recommend setting something like this up early and not relying entirely on Slack, particularly once you have a need for auditability. If someone has a questionnaire, how are you logging access requests? And as you have more employees. Trusted advisor. This is a really Nice thing built into the AWS console, you get a few checks with basic support, and then if you have business level support, you get the whole suite of checks. This just runs automated checks on your account to flag really sort of standard security issues. You can see here that there's sort of one little red issue identified in security. I can't read exactly what it says, but this could be things like, maybe my S3 bucket is open to the world. Maybe I have a host that's allowing SSH connections from the world, et cetera. If you're sort of going into an existing environment and wondering, where do I start with security? Start here. Another tool that, once you've cleared all the issues from here and you're looking to build, more complex rules or enforce more complex policies, AWS has a product called config rules, which allows you to both use built-in rules and define your own rules with Lambda functions for maybe enforcing more complex policies. Again, where do I start? aws.amazon.com/security. This will be your homepage for all of our resources, lists of relevant services, white papers and guides, videos and talks. And then down there is the link to the AWS security white paper. This is it's sort of a fairly comprehensive document on how we think and live out security throughout the stack. So just to summarize, because I am running short on time, visibility. If you take nothing else away from this talk, you have to have visibility. Get visibility, put it in a single place, set up login alerts. You want to know what's going on in your environment because you want to know, you just won't know otherwise. Least permissions, encryption, keeping applications updated, AppSec, Office IT, database and analytics. Again, if single most important takeaway I would say here is to make sure you have visibility, make sure you have logs, make sure you have systems that people agree on and use. And that's all I have. We are at 28 after, so I can take a couple questions. Yes. It's very similar in spirit to Trusted Advisor. So what Trusted Advisor is doing is, it has a rule that says, flag security groups that are open to the internet, and then they just show up as an issue there. Config rules would allow you to, write your own rule that said that, or maybe write a more complex rule that says, only this subnet should be allowed to be open to the internet. And if someone goes in and changes that, then the config rule would change from passing to failing. And you can use CloudWatch events to determine what action occurs then. Maybe I pop a notification in Slack. I should cut a ticket to for someone to remediate this. You can create custom rules both with Lambda functions, and you can also figure out how you subscribe to those events on your own.